All right, here we go. Another practice video for 8th grade standard, Common Core standard for equations and expressions, where we are going to solve simultaneous linear equations. That means two equations that make a line happening at the same time. Woo! Here we go. Fred Snerd wants to take his son, Junior Snerd, bowling. But he also wants to save some money. These are hard times. Lumpy Lanes charges $5 for shoes and $4 for each game. Bouncy Bowl charges $5 for each game, but only $1 for shoe rentals. Now, all these costs are per person, and remember Fred and Junior are both going. These are per person, and the shoe rental is a one-time charge, just in case you've never been bowling before. You need to understand that to work on this question. Shoe rental is just one-time charge for the whole night. Fred has a fresh, crispy $50 bill to spend, but not a penny more. Remember, Fred is paying for both Junior and himself. Help Fred figure out where they should go. Here's your job. Write the equations to represent the cost of each bowling alley. Use algebra. Get this all on one screen for you here. Use algebra to figure out after how many games do they cost the same, and at which bowling alley can Fred and Junior bowl the most games for that $50. Also, you're going to use a graph to represent the situation. You're going to graph the lines for each bowling alley on the same graph. You're going to find where the two lines cross, their point of intersection, and make a note of what the coordinates are for that point of intersection and describe what it means for the situation. And finally, on the graph, can you tell which bowling alley they can bowl the most games at for $50? Okay? So what I'd want you to do in a perfect world is pause the video now so you can have the problem looking at you. Go ahead and do your work and then play it, and we'll compare notes, and hopefully we come up with the same thing. All right? Go for it. Welcome back. I'm going to start with some algebra. We're going to have lumpy lanes, and we're going to have bouncy bowl. Okay, let me zoom in a little bit here so you don't get my high quality tabletop in the picture. Lumpy lanes. $5 for shoes, $4 for each game. Each game means we're multiplying. Okay, when you see a word like each, every, per, etc. Any word like that means you're multiplying. So since we're using y equals mx plus b, remember our slope-intercept form. If it's $4 for each game, there's the multiplying, so that goes there. And the shoes, $5. So there's the equation for lumpy lanes. For bouncy bowl, there's the bell, but my door's locked. I'm going to keep going. Don't worry, I put a sign on the door. Everything's fine. Bouncy bowl charges $5 for each game, so there's the each, but only $1 for shoe rental. So there's the equations. To figure out when they cost the same, we have to understand that the y is the cost. Okay? So since y equals both of these things, we're going to set them equal to each other and solve for x. X equals games. Y equals cost. So if we set them equal like this, that's nice. But remember, Fred and Junior. So there's two people bowling, so it's really going to be twice as much for everything. Okay, so it's going to be $8 a game and $10 for shoes, $10 a game and $2 for shoes, right? Because there's two people, so two of each thing. So we're going times 2 with everything here. Now we will solve for x. We'll take 2 away from both sides. divide by 2, x equals 4. Excuse me. What does 4 mean for this situation? Well, x equals games, the x games, right? So 4 games, same cost. What will that cost be? We can take either lanes, lumpy lanes for example. We can even take that original equation. No, we want to take the adjusted one. Remember, 2 people are bowling here. And we're going to take 8 times 4 games plus $10, $42. Let's test that out by going bouncy bowl. Bouncy bowl, 10x plus 2. If we bowl 4 games there, you can see this happening. You can see it coming, right? There we go. So we just used algebra to figure out the point of intersection, which means that's the point at which both bowling alleys, after 4 games, will have the same cost. Okay? $42 for 4 games. We had one final question here, which was Fred has $50. He has $50. At which bowling alley can he bowl the most games? Okay? So lumpy lanes, we say $50 equals 8x plus 10. At bouncy bowl, $50 equals 10x plus 2. Okay, whichever one of these, remember it's x games, whichever one of these gets the highest value for x is the bowling alley he can bowl the most games at. So, take away 10 from both sides. And divide by the coefficient of x. He can bowl 5 games at lumpy lanes and have not a penny left over. No change, not a piece of gum, nothing. Bouncy bowl. Divide by the coefficient. 4.8. What does that really mean for this situation? Right, you can't bowl 4.8 games. That'd be like you're in the middle of your 5th game and they shut you down. So really what he's going to do here is he can bowl 4 games and he's going to have some change left over. Okay? So if he just wants to bowl as much as he can, he's going to go for lumpy lanes. If he wants to give up a game and have some money left over for a snack, he could go to bouncy bowl. So that takes care of the first part of this problem. Now we're going to do some graphing. Okay? So, every good graph has a title. We'll give this a title, Bowling Night. Since these are all going to be positive values, I'm just going to use a first quadrant graph. That's big enough, I think. If you remember from all that work we did, remember x equals games and y equals money. So since that's the y-axis, that's money, and this is the x-axis, that's the number of games. I'm going to spread these out so we can get a nice picture of what's going on. How you doing? I'm doing good, thanks. Just setting up the y-axis now. Now, if we look back at our algebra, it can help us set up the intervals for our graph. We're dealing with 40, 50, probably 60 or 70. We want to go a little over 10, 20, 30. So I'm going to go by 10, count by 5s over here. So there's 10, 20, 30, and so on. It's very important the decisions you make about scaling your graph. You want to be able to fit all your data in there and hopefully not have a lot of extra empty space. Okay, so there's a good looking graph. I'm going to start off with lumpy lanes. I'm just going to recall the equation over here for lumpy lanes was 8x plus 10. So remember, this is slope-intercept form. So that's slope. This is the intercept, the y-intercept. So I'm going to go to $10. And the slope means it's going to go up $8 and over one game. Since my graph goes in terms of fives here, I'm going to go straight to the intersection. Remember, the intersection was at 4 games and $42. We can use that information from the algebra to actually help our graph look better. 4 games, $42. 42 will be right about there. Sometimes on graphs we have to estimate, which can make our information not completely accurate. So graphing calculators are for. But we can tell a lot of information about something even with a graph that's slightly off. Okay, so there's lumpy lanes. Now I'm going to use red, and we're going to do bouncy bowl, BB. Everybody likes some alliteration sometimes. Bouncy bowl is 10x plus 2. Okay, so we're going to start way down here at 2, because that's the y-intercept. Y-intercept. $2. That's the shoes. They're going to intersect at that same spot, so I'm going to leave that. I'm going to do my best to make this as accurate as we can make it with a ruler and a felt pen, which is kind of tough. By design, it's kind of tough. There we go. Okay, so bouncy bowl is in red, lumpy lanes is in black. Let's go back to our questions. Okay, graph the lines. Done. Find the point of intersection. What are their coordinates and what does this mean for the situation? Okay, we know from our algebra that those are the coordinates. What is the meaning? The meaning is you have to be aware of what the labels for the x and the y axes are. So it means after 4 games, both cost $42. That's the meaning. And then our last question, at which bowling alley can Fred and Junior bowl the most games for $50? Well, let's take a look at our graph here. I'm going to draw a little line here at 50. This is the one that we can bowl the most games at for $50 because it's the line that's furthest over. And remember, furthest over on the x-axis means most games. So, black, lumpy lanes, most games for $50. Lumpy lanes. Okay, which, if we look back to our algebra, backs it up, right? It's pretty close, but the reality of the situation is 5 to 4. And if we look at our graph, we can see it's very close. This represents the 4.8 that we had, and this represents the 5. So it's lumpy lanes. And that's it. Whew, that was huge. But we did it in less than 15 minutes, so that's not too bad. All right. Hope yours went as well as mine did. I bet your graph looks better than mine. And thanks for watching. More to come. Thank you.